Welcome to my presentation. In this presentation, we shall see the proof of the quotient rule and solve some examples related to quotient rule. So let us say we have a function like this. Let y be equal to a function which is in the numerator, which we'll call it as f of x, and a function in the denominator which we'll call as g of x. So then we're going to apply try to prove this quotient rule, and to do that we're going to follow these following steps. Step number 1, apply the derivative formula of limits. So the way we know it is dy by dx is going to be equal to the limit as h approaches 0 f of x plus h minus f of x, this whole thing divided by h. Then we're going to substitute, as the second step, we're going to substitute the given function into the formula. So to do that, we're going to write this one out as limit as h approaches 0. We're going to write this one as follows: f of x plus h divided by g of x plus h, like that, minus f of x divided by g of x, and this whole thing is divided by h, like that. Okay, now we're going to take the common denominator for the numerator part, so therefore we can write this one as follows: limit as h approaches 0. We're going to cross multiply, and then we're going to get, we can write this one out as g of x times f of x plus h, like that, minus f of x times g of x plus h, this whole thing divided by the h times g of x plus h times g of x. We got all the terms we needed. Now the thing we want to emphasize here is as follows: we're going to introduce some new terms. We will add and subtract f of x times g of x so that it does not change the given equation, but by combining and finding the common, we should be able to find the derivative of the given function. So let me write this and then explain it some more. So we can write the next step as follows: limit as h approaches 0. I'm going to open these brackets here and then draw a line here and then write some terms. We're going to write the first one, g of x times f of x plus h, and I'm going to introduce these new terms, minus f of x times g of x, and then add f of x times g of x, like that, minus, and I'll go back to my the black color, minus f of x minus f of x times g of x plus h, like that, this whole thing divided by h times g of x plus h times g of x. We got all the terms. I'm going to close this bracket here. Now, taking g of x common in the first set of brackets and taking f of x common in the second set of brackets, we should be able to simplify that some more. So the set of brackets I was talking about is as follows. Let me put that in a different set of color. If I combine g of x times f of x plus h minus f of x times g of x, if we combine that part of it, and then if we combine the second part like this, f of x times g of x minus f of x times g of x plus h, let me put a bracket there. So if we were to combine them by taking g of x common in the first set of brackets and by taking f of x common in the second set of brackets, we should be able to simplify it as shown here. So let me write here. Limit as h approaches 0, we can write this one as g of x times f of x plus h minus f of x, like that, close brackets, minus f of x, open brackets, g of x plus h, like that, minus g of x, close brackets. This whole thing is divided by h times g of x plus h times g of x, and then I can put close brackets here. I can further simplify this as follows. So I can write this one as individual limits. Limit as h approaches 0. I can write this one as g of x times f of x plus h minus f of x, this whole thing divided by h, like that, minus limit as h approaches 0. Then I can write this one as f of x times, open brackets, g of x plus h minus g of x, this whole thing divided by h. Close brackets, and this whole thing is divided by limit as h approaches 0, g of x plus h times g of x, like that. Therefore, we can simplify this some more as follows. So now, as a next step, we're going to write this one out as follows. We can write this one as follows. We can write this as g of x limit as h approaches 0. This one we can write as f of x plus h minus f of x, this whole thing divided by h, minus, we can pull out the f of x in the second part, like that, and then write the rest in inside the limits as h approaches 0, we can write this one as g of x plus h minus g of x, this whole thing divided by h, close brackets, and this whole thing is divided by limit as h approaches 0. We can write this one as g of x plus h times g of x, like that. Now, as a next step, we can see that as h approaches 0, then g of x plus h approaches g of x. Okay, so therefore we can write this one as follows. We can write this as g of x times this part here. I'm going to show this in a different color. This part here, this part is nothing but f prime of x. This is f prime of x, like that, minus f of x times, and then this part here is g of x, g prime of x, sorry, let me write it in the same color. This is g prime of x, like that, and this whole thing is divided by g of x. This whole thing is raised to the power of 2, like that. So therefore, if we look at this, this is what is called, this is the derivative of the function. This is the quotient. This is the quotient rule, basically. If we look at this, we have the second function, the derivative of the first function, minus the first function, the derivative of the second function, divided by the denominator function raised to the power of 2, the second function raised to the power of 2. So that is how we want to be able to show the proof of the quotient rule. In my next presentation, we shall see examples using the quotient rule.